Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Amirah. With my group member ZULHASNITA, we'll present to you the answer for question 1 of the mini project. Before we start, let's look what you will get from this video.
Today, we'll talk about bond price, bond duration, effect on bond price, and bond price with different yield. The question is, a 5-year bond with a yield of 11% continuously compounded pays an 8% coupon at the end of each year. So, a 5-year bond with a yield of 11% continuously compounded pays an 8% coupon at the end of each year. Therefore, at the end of each year, for 5 years, it will pay 8% coupon rate. For the face value, we assume that the face value is 100, discount rate it is given 11%, time to maturity is 5, and coupon rate is 8%. For the first question, it asks for the bond price. To find the bond price, we will use the Excel using PV formula, where it needs rate, number of period, payment per period, FV, and type. For the type, it is either 0 or 1, which is we choose 0 because the question asks for at the end of the year. First, we need to insert all the data given, which is face value we assume 100, discount rate 11%, time to maturity 5, and coupon rate is 8%. We need to change the continuous compounded rate into the periodic interest rate because PV formula in the Excel use periodic interest rate. Therefore, we use the formula of R equals to M times E to the power of R over M minus 1, where M is the number of times compounding take place in a period, R is the continuous interest rate. So we insert the formula M equals to 1 because at the end of each year times exponent 11% over 1 minus 1. Then we will get a value of 0.11627807 for the interest rate periodic. After we get the periodic interest rate, then we can find the value for the price of the bond, which is it use the PV formula. PV, first the rate is 0.11627807, which is the new periodic interest rate, and number of period is 5 because we are using 5-year period, and the payment per period is 100 times the coupon rate, and the FV is 100, the type is 0 because at the end of each year. Then after inserting all the value, we will get the price of the bond, which is $86.80. Next is calculate the bond price in manual. We use the formula of B equals to C E negative YT, sum of those, plus with F plus C E negative YT. So C is equals to 8, Y equals to 0.11, F is equals to 100, which is 8E negative 0.11 times 1 plus 8E negative 0.11 times 2 plus 8E negative 0.11 times 3 plus 8 times E negative 0.11 times 4 plus face value plus C times E negative 0.11 times 5. Then we will get the value of 86.80. Therefore, the bond price is equals to $86.80. What is the bond duration? For the bond duration in Excel, we use Macaulay denominator. To find the Macaulay denominator, we need to find the cash flow, discounted factor, discounted cash flow in order to get the Macaulay denominator. First, for the cash flow, to find the cash flow, we need to multiply face value 100 with the coupon rate, which is 8%. Then we will get 8. And at the last year, which is 5, we need to plus 8 plus with the face value. And for the discounted factor, we use the formula of 1 over 1 plus I, which is the periodic interest rate, 0.11627807, to the power of the period. Then we will get all this value. For the discounted cash flow, we need to multiply the discounted factor with the cash flow. Then we will get the answer for all the discounted cash flow in 5 years. And to find the monthly denominator for 5 years, we just need to multiply the discounted cash flow with the period. Then we will get all the value that is needed in 5 years for each year. All the monthly denominator, we can find the bond duration. To find the bond duration, we need to sum up Macaulay denominator divided by the price of the bond. Then we will get the bond duration, which is 4.26 years. So to calculate the bond duration manually, we use the formula of D equals to the sum of T times C times E negative YT over B. So we substitute all the value given. Then we get D equals to 1 over 86.80 times A times E negative 0.11 plus 2 times A negative 0.11 times 2 plus 3 times A negative 0.11 times 3 plus 4 times A negative 0.11 times 4 plus 5 times 108 times E negative 0.11 times 5. Then we will get the answer of 4.256 years. This is the duration of the bond. Next is, what is the effect on bond price when it decreases to 0.2%? Therefore, we will use the formula of delta B equals to negative BD delta Y. The effect on the price of a 0.2% decrease is equal to negative B, which is the price of the bond, times the duration of the bond, times the decrease, which is 0.2%. Then we will get the value of 0.7388. Then, by using this value, we can find the bond price increases, which is we need to sum this value with the price of the bond. Then we'll get a total of $87.54. Therefore, the new bond price is $87.54 when it decreased to 0.2%. Next question is, what is the bond price with 10.8% yield? Therefore, we will use the first formula, the earlier one, for the question A, the same formula, but we only change the discount rate from 11 to 10.8%. Therefore, like the first step, we need to change first discount rate to the periodic interest rate, which is I equals to M times E to the power of R over M minus 1. We will get the value of I equals to 0.114047745. Then, for the bond price, we need to use the formula of PV, which is equals to negative PV rate, which is 8%, number of period 5, payment per period, which is 100 times 10 times I, the LV, which is 100, and 0, because we use at the end of the year. Then we will get $87.54. Therefore, the bond price is equals to $87.5, and the answer for D is equivalent with answer in C, the question before, which is equivalent to this value. Thus, it is true that the value in D is equal to the value in C. To calculate manually for the bond price, C equals to 8, Y equals to 10.8%, F equals to 100. Bond price is equals to 8 times E negative 108 plus 8 E negative 108 times 2 plus 8 E negative 108 times 3 plus 8 E negative 8 times 4 plus face value plus C times E positive 0.8 times 5 negative equals to 87.54. Therefore, the bond price is equals to $87.54.
To conclude this video, let's review back the formula we learned before. For bond price, the formula is the sum of C exponent to the power of negative YT, where T is equal to 1, 2, 3, and so on, plus F plus T times exponent to the power of YTN, while bond duration formula is equals to the sum of T times C times exponent to the power of negative YT divided by B. And lastly, the effect on bond price formula is delta B equals to negative B d delta Y. That is all from us. Thank you for listening.